Homework Hotline is a production of the Knowledge Network of Greater Omaha, originating from the Career Center of the Omaha Public Schools. Homework Hotline is made possible in part by Nebraskans for Public Television.
Homework Hotline and Kapow make math and science a blast. Watch and take part in Homework Hotline and you could surprise your classmates with a performance by Kapow. Your school could win a fun-filled, action-packed performance of Kapow, Chemistry and Physics on Wheels, courtesy of Homework Hotline. Just call a live Homework Hotline broadcast with your math question or problem. Give us your name, school, grade or age, and your phone number and a really tough math problem, and we will automatically enter your school in the Kapow contest. Emails count too, but each person may only enter once per week for their school. See the Homework Hotline website at www.homework.unomaha.edu for complete rules and details.
That's right. Give us your name, school, grade or age, and your phone number, and a math question for us to work tonight. And that will enter you and your school into the Kapow Science Contest. Welcome to Homework Hotline. I'm Heather Harbison from McMillan Magnet Center.
I'm Paul Jensen from Burkeye. Tonight we inviting all our secondary students to call in with their homework questions. Take out a legal pad, calculator, and we are happy to assist with mathematics, isn't it, Miss Harbison?
It is mathematics. Geometry, algebra, fractions, integers, decimals.
Yes. What's that show that's on Monday night? What's that all about?
Oh, that's the elementary program. So if you're in K through 6, you probably want to call on that Monday night because they're really good. I've seen those teachers on that. They're really good. I hope someday I can be just like them.
They are good.
They are good.
Well, fewer mistakes than what we make here.
Well, all right. We're not perfect. We never said we were, Mr. Jensen.
Well, if you want those phones to ring, then you have to make a few mistakes, and then people will tell you.
Most definitely.
Yes.
And we have some young ladies here from Monroe. We're happy to have them. We'll introduce them a little later. So if you want to give them a call, give them your math question tonight. Mr. Jensen and I, or even our phone operators back here, might be able to help you to do that math. I know we're getting towards the end of school. Talking about the Kapow contest early, you know, this week and next week, and then it's over.
This week, next week.
And then we have one more show.
One show after that, and then.
But the Kapow contest ends next Tuesday.
Yes, so they have to get those calls in.
That's right, and I have here who's in, isn't this, do we even want to say that?
Hey.
Oh, yeah, we can.
That's too
They're here
coincidental.
tonight.
Monroe
is in top.
First place.
First place.
It's got anything to do with the teacher or what?
I don't know.
She's over there working so hard. She told me she didn't want to be harassed this evening. So.
I know, you about scared her out of here.
Oh, Mrs. Corsair, please, we want to scam you with this camera from the ceiling.
I told her she could take my place. I'll be happy to.
I could go sit down.
Yeah.
I would learn something.
Oh, well, what are you going to teach us tonight on the first problem?
Averages.
Averages.
If you know your average now and want to know what you need in the future to determine a certain average where you want to be, now's tonight. Tonight's the problem. Tonight's the night.
So you think I might be worried about my algebra grade?
Well, you might be back in middle school again.
Oh.
How long you been there? You can't seem to get... I mean,
it's only taken me 7 years.
I've been stuck where I am for 10, but
wow.
I hope to be there another 20. People say, Mr. J, when you retire? And I said, could be a year, could be 20. I can't figure it out.
Keep them guessing. Yeah. I like that. All right, averages. We're ready. Mean?
Mean.
Mean.
Let's not be.
All right, let's be nice.
We are talking about averages this evening. How to find the mean is the technical term. The statistical term is how do you find the mean. Well, a lot of you are thinking, I know how to do that, Mr. J. It's a matter of taking my 4, my 5, my 6 numbers. So whether you're age 65, 35, we'd like to invite everybody to take a look again, if you would, at how do you calculate the average for anything. So since we're wrapped up in the end of the school year, we might find that you have accumulated some scores, and they are the following 4. Once again, may I ask you this evening, how would you find that average? How would you find the mean? Well, you're thinking, well, yeah, Mr. J, you just take these 4 numbers and you find their sum. Well, we pick up a 5, 16, 23, carry the 2. We might be looking at 335. Let's see, 5, 16, 23. And then to find the average, we divide that by 4. So without the use of a calculator every single time, we know 4 will break into 33. Right, 8 times. What happens when you subtract? Sure, you pick up the 1 almost 4 times, 83.75. It's close to 84, isn't it? So the average of these 4 numbers would be about 84%. Well, the question this evening is something a little bit beyond just finding your current average. And so if you're watching this evening and you have access to all your particular grades that you have received, and you're thinking the following, I wonder what I must do in the future to attain a certain average. And maybe you've wondered how to do that. How can you calculate that? And that's where algebra comes in very nicely. Let's say that we're pretty late into the second quarter, into the second semester, and so you may have picked up a lot of scores. My students at this point have 7 grades, each one representing about 2 weeks worth of algebra. So let's imagine that a certain student has 3, 4, 5. These are the numbers that come up. What would be the average? And then once we find that, let's determine what would this person need the next number of tests to get to a certain point. So I guess for the sake of simplicity, let's say, of course, in OPS, a 1, an A, would be a 93%. Let's say a 90 would be an A, just for the sake of simplicity. A C would be a 70%, and a 60 would be a D, and on down the line. But we're not going to entertain the fact that we're looking at scores below 70%. Let's take a look at this person. Let's say they're trying to get a 1 average. Do they already have it? What would they have to do to maintain it? So if we take the sum of these 7 numbers, and they're all zeros except for that 5, we have 16, 24, 34, 42, 51, 61. I believe that's 615 points that have been accumulated. 16, 24, 34, 42, 51, I think that's 615 points. And this person knows that in my class, 1, 2, 3, 4, 5, 6, 7, and 615 right now divided by 7, 7 and 61 is a number, the number 8. 8 times 7 is 56. 56 from 61 is 5, and 7 and 55 is about 8. So right now they have about an 88% average. But imagine up here that they want to move that up into the 90 bracket. And all this time they've been accumulating this so-called B average. Now with 7 numbers already in the grade book, there's only 3 grades left in my classes where they can maybe move this up to a 90. There are 3 more tests or 3 more progress reports. That'll give us a total of 10 numbers. And we like this person to average. This person wants to bump that up to 90. How would you do the algebra? All right. Think about what is the reasoning behind this process. They already have 615 points. There are 3 more reports, 3 more unknowns that they must come up with, so that when they divide this by 10, because there will be, by that time, there will be 10 numbers. 1, 2, 3. We're looking up here a little bit. 4, 5, 6, 7, and there will be 3 more numbers to be concerned about. All that divided by 10, and we want to raise that up to a 90 average. If we solve this algebra equation, we will then know on the average what must they get on the next 3 reports. Well, to solve this, think about how would we isolate the x? How can we isolate the variable, the x, to determine what they need on each of the next 3 reports? And that's assuming on the average, what will they need? Well, to solve for x, we need to begin to unravel it, and the inverse thing to do is take both sides times 10. These 10s will cancel out, won't they? And 10 times 90, of course, is 900. As you can see, 10 scores, 10 into 900 would be the 90%. We're down to 615 plus 3x. If we subtract 615 from 900, 600 from 900 is 300. Drop the 15, I think, is 285. Dividing both sides by 3, and we'll go back and check our work. We know that 3 goes into 28 9 times. 9 times 3 is 27. 1 left over, and 3 into 15 would be 5. So this person needs 95 on each of the next reports or higher to get an A instead of a B. Or it really doesn't matter how they split up the 185 points. One time might be 95, next time could be 93. I suppose the next time would have to be 97 to get this up to 285, just so they have accumulated 285 points on the next set of 3 tests. So perhaps you're wondering tonight yourself, how can you take a certain average and move it up to a higher one, hopefully not a lower one? Sometimes students would say, whoa, I've got that 88%. All I care about is keeping my B. What was that, 615 plus the next 3, then we'll get back to Miss Harbison. Divided by 10, because after the school year is over, like we said, in this case there would be 10, and suppose they just want to get an 80. I'm afraid they have set their sights too low, almost afraid to work it, unless somebody's watching and thinking, what's it take just to maintain a B? Well, to multiply both sides again by 10. In other words, 800 divided by 10 to get that 80. When you drop 615 from 800, 600 again from 800 is 200, and another 15 down is 185. So we've set our sights, of course, way too low, dividing both sides by 3. 3 into 18 6 times, 3 into 5 once, about twice. Yeah, that's a pretty low standard, but a 62 on each of the next reports would maintain the B. Too much information, maybe? Always set your goals, set your sights for something higher, but that's just how the math works. It's fairly cold-blooded, fairly objective. It's black and white. Numbers don't have much emotion to them. So the issue is go for the A. Don't just try to keep the B. Ms. Harbison.
Well, Mr. Jensen, I think I have to stay in junior high next year.
And why would that be, Miss H?
Well, I was figuring my algebra grade, and I just don't know.
Well, there's a lot of ways to get around that. Money under the table will move people on.
Oh.
2, a big stack of donuts, depending on people like me. Or 3, just hard work. What are you going to do?
I guess I better kick that hard work. Huh.
See, with 5 weeks left, staff, the kids, we're all thinking, whoa.
I know.
We have to work hard.
All right, I'll try.
Did you get any questions?
I don't have any questions, so that must mean that
Got some, I don't,
this one, I looked at that one. I thought I'd leave that one for you.
Directrix, Jenny Cook. She's one of
Are
mine.
you doing directrix?
We are.
You want to do it right now?
I'd love to, if you
I'll
don't
let
mind.
you. Nope, go ahead.
Jenny. Thank you. Yes, Miss Cook. You know what this means. And thanks for suggesting something from second-year algebra. Okay, well, hang on to your toupee, hang on to your wig, hang on to your brain, everybody who's been out of algebra for a long time. Jenny Cook is from Burke and asking us, given this equation, can we go ahead and find what's a thing called the directrix, So once we find it, we'll sweep it up to the top of the board, the directrix. And so for all those watching tonight are wondering what in the world is a directrix, and you're curious, you're just a curious person. Yes, Mr. J, I've had algebra second year, I've had it in college. Can you help me refresh my mind how to find the directrix? The topic under discussion was parabolas. Let's see, how can we explain what parabolas are? Let's take well, I guess if you take a cone, parabola. Yeah, I can get a parabola out of this. You take a cone like an ice cream cone and you slice it various different ways, you get various shapes. If you take a plane, so to speak, or if I might say run a slice straight across, and take the slice out, it will be in the shape of a circle if it's parallel to the base of this cone. That's how you can, these are called conics. A circle is a conic, so is an ellipse, so is a parabola, so is a hyperbola. So if you make a plane, a slice, a plane that cuts right through that cone, out comes a circle. If you tip that a little bit, do a diagonal cut, you get an ellipse, kind of like a track or an egg. If you take a slice parallel to the nap of this cone, this is called the nap, and it's parallel, you get a parabola. And parabolas are shaped like this. They kind of look like U's or upside down U's. They can, when we go to graph them, there are 4 different ones that we're very concerned about. That's the slice you get. If you, let's see, take a double nap cone, that would be 2 cones sitting on their heads, and you slice it this way, you get a thing called hyperbolas. And hyperbolas will have what look like 2 branches a little bit. You get one out of this, and you get one out of the bottom one if I were to cut that more carefully. So we're talking about some geometry, mixed it with some good dose of algebra. So we know that Jenny Cook is looking at this equation. It's a quadratic, and yes, Jenny, this is a formula for that of a parabola. Let me show you what that looks like if we graph that on a 2-dimensional XY plane. The formula for a parabola when x squared pops up is 4py, where this talks about the focus, the focal point, the focus of a parabola. So we got to get 5 to be equivalent to 4p, and we know that this 4 times whatever must be equivalent to 5, or just 5/4. 4 times 5/4 is 5, and what that tells us when we discovered the value for p, that is called the focus of a parabola. So we take a moment, go to graph it. We know that parabolas that are of the x squared nature, that's the kind that open up or open down. If it happened to be y squared, 4px, then that would tell us that the parabola kind of looks like the letter C or a backward C on a xy plane. So we've gone ahead and limited ourselves to forcing the index to be situated at the vertex of the parabola, at the origin of an xy plane. So x squared, since there's a vertical axis that goes through it, we know that 5/4, being positive, is sitting right here, 1 1/4. That is the focus. Whoops, it's x squared. So I'm up here on the y-axis at 0, 5/4, with the vertex of the parabola sitting there at the origin. And Mr. J, what's all this mean? Let's see if I can make some practical sense out of this. A lot of you are sitting there wondering, what in the world? Parabolas, they're found in the real world as satellite dishes. A satellite in your backyard is probably in the shape of a parabola. A ray comes down, a beam comes down, bounces off it, and on many occasions there might be, this is called the focus. It bounces off this parabola into the focus. If you wanted to convert solar power into hydropower, that is heat water via the sun, every time a sun ray hits the plate of a satellite, it's designed as a parabola to shoot back up into that focus right there. So if you do this a million times with sun rays, all converging back at the focus, you can imagine a lot of heat's being generated at that point. It probably is energized down through a rod, and then there's a whole set of mechanical apparati to force that into moving turbines through probably hydropower. So getting that water heated, turning the turbines, then you have energy generated not by always coal, but by solar power. So I know out in the Mojave Desert there's acres and acres of these panels, all in the shape of parabolas, where they're trying to generate energy or electricity via solar energy. So a parabola in the real practical sense can be a satellite dish. It's kind of like a magnifying glass in reverse. You're trying to soak up that heat or get it concentrated. So here we're at this focus, and we're just now going back to speaking abstractly. That's the focus. Also, it's true that when you run a line segment from the focus out to the parabola, it will project down, like if this was 8 feet, this would be 8 feet, into a line called the directrix. Or if this was 9 feet on a huge satellite disk, it would project down 9 feet into the directrix. If this is 4 feet, that'd be the midpoint of a line segment from the directrix up to the focus. So that's 4 feet, that'd be 4 feet. So all these points bounced into this directrix. And so if that is 5/4, 0 5/4, Jenny, then the directrix would be the opposite of P, in this case the opposite of 5/4, and because this line is horizontal, that's y equals a negative 5/4. So we know that horizontal lines on the XY plane are explained by the equation y equals. So Jenny, I'm pretty confident that made sense to you. For all of us who are seeing this for the first time, it's just a lot of things coming at you, but thanks for trying to understand it. There's a lot going on there. Let me get back to Miss Harbison, because I've been doing all the talking.
Oh, all right. That means I have to work, huh?
You do. You need to, I want you to work really hard.
Okay.
I want make only 2 mistakes, so when you make mistakes, and I can make some, and we're just like even here tonight.
Oh, okay.
I think I made a few already, but nobody's calling me.
Well, I like that because we just, in Algebra 1, since I teach Algebra 1, we just started quadratics today.
Quadratics? And you're looking
Quadratics.
at parabolas.
We are. We started talking about parabolas. I said, look, you learned a new vocabulary word. Go home and impress everybody that you can say parabola.
Parabola. There's a snake called a parabola. You ever seen one of those?
No, I don't want to see any snake.
Oh, yeah, parabolas, they're dangerous. They swing like this through the jungle.
Oh.
It's really bad when they go like this, because then they're coming after you, Miss Harbison.
Okay, well, I'll stay out of the jungle, away from those parabola snakes.
Do that. They're very poisonous.
Keep them out of Omaha.
Now, pythons aren't.
Oh,
No, boa constrictors?
yeah.
Watch out for a parabola.
Okay, I'll remember that next time I go to the jungle. Anyway, let's do a little algebra today. I have a call from Tiffany at Sunny Slope. She's doing a problem that we could use some algebra on. It's a pretty easy basic equation. It says 2x plus 1 equals 5. And you can use guess and check, but if we wanted to do this algebraically, if we wanted to solve this and isolate that variable, how would we do that? That's our goal, to figure out what number we can put there for x. And you can guess and check, and this is a problem that's probably pretty easy and would be easy to guess and check. But let's do some algebra using some algebra and some inverse operations. My goal is to isolate x because I want to figure out what number I could put in there for x. So that means I need to undo or get rid of what I'm doing to x. Notice here, if I read this problem, it says 2 times x plus 1 equals 5. So make sure that you at least read the problem. 2x plus 1 equals 5. We want to isolate x, so I want to get x by itself. That means that I need to make plus 1, I need to get rid of this plus 1. The only way to undo an operation is to do the opposite. Well, adding 1, the opposite of adding 1 is taking away 1 or adding a negative 1, because we want that to end up as 0 over here, because anything plus 0 is always that number. What we do to one side of our equation, we have to do to the other. So I bring down my 2x. 1 minus 1 cancels. That's equal to 0, so I can cancel it out. Equals 5 minus 1, which is 4. One more step. This is a two-step equation. One more step that we can do to isolate x. Notice here I'm multiplying by 2. I don't want to solve for 2x's. I want to solve for 1x. So to do that, I'm going to divide by 2, because I know 2 divided by 2 is 1. If I divide the left side by 2, I have to divide the right side by 2. So 2 divided by 2 leaves me x, or 1x, equals 4 divided by 2, which is 2. So x has to be 2. If we plug this back in here and check it, 2 times 2 plus 1 equals 5. 2 times 2 is 4, plus 1 is 5. So 5 equals 5. We can check it. Well, let's kind of take off of that and let's try another one. Let's try one that says negative 3 times x plus 2 equals, we'll say, a negative 12. Now notice here, we've thrown a couple of other things in there, and a real important property that I want to talk about in algebra, which is called the distributive property. Notice that over here, we had 2 times x. That was 2 times the quantity x. We could have written it 2 times x. We could have written it 2 with parentheses x. This is the same thing, except for we're not multiplying a monomial, or one term times another one term. Actually, we're multiplying what's called a monomial, this constant, by a binomial that has 2 terms in it. We're taking a negative 3 times everything in the parentheses. And this is where the distributive property comes into play. Distributive means to distribute, and that's what I'm going to do. I'm going to distribute this multiplication to everything in the parentheses. So I'd actually have a negative 3 times x plus, I distribute again, a negative 3 times 2. We just wrote that out, equals a negative 12. So negative 3 times x and negative 3 times 2. Notice I multiplied that negative 3 times everything in the parentheses. I distributed that multiplication. Negative 3 times x is negative 3x plus negative 3 times 2 is negative 6 equals a negative 12. Now it's a problem like we had over here, and we use inverse operations to solve this. I want to undo adding a negative 6, so I want to make it equal 0. So I add a positive 6, and I do that to both sides. I bring down my negative 3x. Negative 6 and a positive 6 cancels. Negative 12 plus a positive 6 is a negative 6. What do I do now? I don't want to solve for negative 3x's or negative 3 times x. I want to solve for 1x. So to do that, instead of multiplying by negative 3, I'm going to divide by negative 3. Negative 3 divided by negative 3 is x equals negative 6 divided by negative 3 leaves me with 2. Can we check that? Plug that back in there. Plug that in for x. 2 plus 2 is 4, and 4 times negative 3 is a negative 12. So that kind of helps you. Building on that distributive property, when we use distributive property, we did it in some basic equations. Let's take it one step farther. We took a monomial times a binomial. Well, let's say that we have a problem that says this: x plus 6 times x minus 1. You look at that and you say, oh my goodness, what do I have there? Well, here I have x plus 6, the binomial, because there's 2 terms there, multiplied by another binomial, because there are 2 terms there also. We can do the distributive property, and also when we multiply 2 binomials, we have an acronym that helps us, and that's FOIL. First, outside, inside, last. And that has to do with what we're doing. We're going to distribute. Notice that I'm multiplying every one of the terms in my first parentheses times every one of the terms in my second parentheses. X plus 6 and x minus 1. To make this a little easier, this minus 1, we're going to change that subtraction to an addition problem. So this would be x instead of minus 1 would be plus a negative 1. We're going to distribute. We're going to do this 2 ways. We'll use distributive property first, and then we'll also do FOIL. Notice here I'm going to multiply. I'm going to distribute this multiplication of x to everything in that second parenthesis. So x times x plus, and notice I have all pluses, x times negative 1, so negative 1 times x. We're going to distribute this now because we're moving over, plus 6 times x plus 6 times negative 1. Notice I distributed the x, and I distributed the 6, right? I used the distributive property. So x times x is x squared, plus negative 1 times x is plus a negative 1x. 6 times x is plus 6x, and 6 times negative 1 is a negative 6. You say, oh, look, I can combine some like terms. Those 2 terms in the middle, they're both to the same power, so I can put them together. So I end up with, if I simplify this, x squared plus 5x plus negative 6. And right now it's not set equal to anything, so we're not going to solve it. FOIL uses the same kind of idea, and it's just a way to remember how to do this. FOIL stands for first, outside, inside, last. First, you multiply the 2 that are first in your parentheses. So we have x times x. So first, x times x. Okay, x times x is x squared. Then we multiply the two numbers, or the two terms that are on the outside of our parentheses, the O. So x times negative 1, and that's negative 1x, or plus negative 1x. All right, I've done the first, the outside. I now do the inside, the 2 on the inside of my two sets of parentheses, 6 times x. So plus 6 times x, which is 6x. And then I do the last, the two that are last, the two terms that are last in their numbers. So 6 times negative 1 is a negative 6. Notice again, I can combine those middle terms, negative 1x and positive 6x gives me 5x. So I end up with the same thing. So distributive property is also used when we multiply binomials, two binomials. Notice I use the distributive property. FOIL is a way to remember how, or you're distributing that multiplication to everything in both of those parentheses. So FOIL and distributive property are two properties, or at least distributive property and FOIL is a help with that will help you to multiply monomials times binomials, binomials times binomials, all of those algebraic terms that we use. So, Mr. Jensen.
We are ready to introduce.
My goodness. Already? I've just been blah, 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 blah. All right, let me start over there next to Mr. Jensen. This is Carolyn Keenan. She's a 7th grader. She comes to us from Honors Math at Monroe in Mrs. Corsier's class. And all three of these ladies are all in the same class. They're all in the same Honors Math, so we're glad that they're all three here. Next to Caroline is Kylie, I'm going to say her name wrong, Galindo. Nope, I messed up. Galindo. Oh, there I got it. Kylie's also a 7th grader in Mrs. Corsier's Honors Math class. And last but not least, over here by me is Ashley Davis. She also is a 7th grader and also comes to us from the same class Kylie and Carolyn came from, Ms. Corsier's Honors Math class. So we are glad these young ladies are here. If you haven't had a chance to talk to them tonight, give them a call. They're waiting to take those math problems, and we will be right back to do those math problems. And contest question?
Yes.
All right, we'll be right back.
Homework Hotline and Kapow make math and science a blast. Watch and take part in Homework Hotline, and you could surprise your classmates with a performance by Kapow. Your school could win a fun-filled, action-packed performance of Kapow, Chemistry and Physics on Wheels, courtesy of Homework Hotline. Just call a live Homework Hotline broadcast with your math question or problem. Give us your name, school, and a really tough math problem, and we will automatically enter your school in the Kapow contest. Emails count too, but each person may only enter once per week for their school. See the Homework Hotline website at www.homework.unomaha.edu for complete rules and details. Watch Homework Hotline and call with your math questions Mondays and Tuesdays at 4:30 on KYNE-TV, Channel 26.
Let's take a look at the homework or the contest, Homework Hotline contest question. It was similar to the model that we had up here earlier. Let's imagine that a person has the following 7 scores, and for the sake of simplicity, we'll call an 80 a B, a 90 would be an A, a 70 would be a D, and a 60 would be an F, or lower. And this person has a feeling that they got B's, D's, there's an F, got a couple A's, and they're thinking, wow, you know, I'm close. It feels like I'm in the 80s maybe. But they have a dream. And by the end of the school year, they like to have a 90% average. But to do that, not only do they need to keep track of their current average, these 7 scores add them up, divide by 7 would tell them currently if they're in the ballpark, are they even close to reaching up to 90, or perhaps already in the 90s. But with only 2 scores in the 90s and the rest lower, it's going to be a pretty good challenge to get that up to 90. But there is a dream, there is a hope, a possibility that given the next 3 progress reports or 3 tests, all of equal value, all of equal weight, equivalent as much as an 80, that's an 80, and that turns out to be a 92, they're equally weighted. We could say that with this information, plus the next 3 missing reports, what would it take to average out to a 90%. In other words, that total divided by 10 has to be 90%. Now my question is, this evening, on the average, what do each of these have to be? Well, you're thinking, well, I don't know if I need algebra, Mr. J. I can get those total up right there. Well, I'm just asking, what's X? What's X? On the average, what do they need on the next 3 reports? Call it in, give your name, address, phone number, school if you will, or if you're out of school, like one week we had a grandpa call in. That's so great. If you've been out of school a long time, you just want to win it for a niece, a nephew, a kid, a grandkid, we invite you to call it in. Give your name, and if you want to mention the high school you attended, if you're not too scared, mention when you left high school, that'd be great. We'd just love to have anyone participate in the contest this evening. Tilt family is sponsoring the contest, and they will send out a mini golf ticket to someone who wins it this evening. So again, the present scores plus the future in such a way we average out to a 90%. Is it possible? Well, the number will come down, but is it even possible? We're not asking. This evening, if it's possible, we just want to know, what is that number? Can you find it? Other questions that have called in this evening, for the contest question, there's probably 15 minutes left on the competition, so call it in. Christina did call in from Morton, asking us to take a look at, and Christina, we may not have this down exactly what you mean, because I'm looking at a couple parts here. That number, whatever, divided by 3 has to equal 10, and I guess the only thing I could figure out from this, is it true or is it false? We know that 5 times 25, in this case a negative 125, divided by 3, when you go to simplify that, will not be 10. Perhaps this was a variable. We're not quite sure what's on the paper, but if you were to solve it, the answer would be negative 125. And that is not the best looking notation for that. Let's rewrite that. Negative 5 times 25, it might be more understandable if we put it this way, divided by 3 equals whatever. If that's the case, then Christine, we have negative 125 over 3, and that's what the value is for X. And a lot of folks are out there trying to say, well, Mr. J, that's not reduced, and it certainly is reduced. Perhaps you want to make it a mixed number, but it's reduced. It might go in there like 41 times 2 left over, negative 41 and 2/3, or a decimal of 41.6 repeating, but it certainly is reduced. There's a general pattern of thinking out there in the community. Sometimes we're taught that a number like 8/3 is not reduced. It certainly is. Maybe you want to make it a mixed number, 2 and 2/3. Perhaps you want to make it a decimal, and that'd be 2.6 repeating. Perhaps you want to round it off to the nearest hundredths, and that'd be 2.67. Or the nearest tenths or hundredths, but that is reduced. Well, if you saw a problem like this, you say, well, Mr. J, that's not reduced, which is true. You can take 4 in the 12, 4 in the 8, and you come up with 3/2 as your reduced answer, but that is reduced. Especially in high school mathematics, some of the upper courses, particularly in trigonometry, where fractions is exactly what we're looking for. Often we like to leave things in fraction form. Remember, last week we said a fraction, it can be understood on the technical term, rational number. A rational number is something over something, given that the denominator does not equal 0. Leora called in. She has this question, and she's probably working on parabolas, and I think the question might be here, how can we move that into standard form? The standard form for this type is y squared equals 4 times the focus x. So we're not quite there yet, Leora, but we will be there soon. To remove the 1/9, we think about reciprocals, don't we? So they cancel out, and then 2x times 9. That gets us, Leora, down to y squared equals 18x. Well, we know that 18 is equivalent to 4 times something equals x, this being the focus, being the value for p, tells us the focus, or in this case, if you multiply by 4 and divide by 4, you still have the same problem. 18/4 reduces to 9/2. And 4 times 9 is 36. Divided by 2 is 18. These are equivalent. These are called equivalent equations. So if we clean this up a little bit, Leora, we have 4 times the value for p, which is 9 over 2. And that would be followed up with the value of x. Good question, Leora. We're not, maybe the question was, can you get that in the standard form? If you're asking for focus and directrix, we'd have to take a little farther. Perhaps Amber Sutton, who called in, we'll get back to Miss Harbison. Maybe, Amber, I have the problem in front of me. I'm not sure what you're asking. Perhaps you're asking for, what's this look like in standard form? And then beyond that, what's the focus? Beyond that, what's the directrix? And beyond that, perhaps we ought to graph it. So why don't we do all 4 features? And Amber, I'm sure that will cover it. Well, to get that into standard, we need to add 4y to both sides. We need to divide by 3. And so we're looking at 4/3 y. We know that standard form for parabolas is something called 4py. So 4p is equivalent to the 4/3. 4p is equivalent to the 4/3. And if I multiply by 4 and divide that number by 4, which is 4 over 12, I think I still have the value of 4 here, of 4/3. Let's see. I think I lost it. That's not right. Or I don't think it's right. Let me back this up. So, yes, I got the 4. I know if I take 4 times 3 is 12. Let's see, that's 1/3, isn't it, reduced? And 4 times 1/3 would be 4/3, so I'm in good shape there. So that's the standard form. The second question might be from Amber is, can we find the focus? Well, we know the focus is either 0p or p is 0 because it's an x squared type. That's the tip-off that the parabola opens up or it opens down. Therefore, to get the focus, it's going to have to be 0p, in this case 0 4/12. I guess we better say 0 1/3 if you reduce it. The directrix is the opposite of p. Directrix, and in this case, let's see if we get a sketch going here right away. We might find that we are making more sense out of this on an xy plane. Focus is at 0 1/3, up 1/3. The directrix is a line parallel to the x-axis, and so if we get a little sketch going of the parabola, this point bounces off, and if that's 4 feet, that'd be 4 feet. If that's 6 feet, that'd be 6 feet. If that's 12 feet, bouncing off the parabola, this line segment from the parabola to the directrix would also be 12. That's the meaning of, and the purpose of the directrix, is to find that line where the focus bounces off. A line segment between the focus and the parabola is of equal length from the parabola down to the directrix. Well, because this is a horizontal line, we know that it has to be y equals the opposite of p, and the opposite of 1/3 is negative 1/3. So we're down 1/3, we're up 1/3 to the focus. Great question. Second year algebra, dealing with parabolas, their features, properties, finding focus, finding directrix, finding standard form, and perhaps even sketching them. And I probably, Ms. Harbison, have done enough of those to drive everybody crazy. What can you do for us?
Well, we're going to use the quadratic formula over here.
Whoa.
Quadratic formula.
I like
was
the
given this question, Alex called in from St. Bernard's, and he had this equation that said 51x minus x squared or plus a negative x squared equals 32. And we want to solve for x. I'm assuming, Alex, that's what I need to do. So notice I've already done a little bit of the work to set this up. Is what I wanted to do is I want to solve for x. And notice this is what we call a quadratic equation. So I want to figure out what value could I put in for x that would prove this equation true. Well, to do that, first of all, I did some things where I put all of my variables and numbers on the same side. So I added x squared to both sides. I ended up with 51x equals x squared plus 32. Then I subtracted 51x. And what I want to do is I want to set it equal to 0. So I can either factor it, because this x squared throws a little, kind of a little monkey in in this problem because we can't just solve for x, okay? X squared, the inverse of x squared is square root of x squared. But notice we also have an x in this. So I can't take x out of them. I can't pull an x out. So we're going to have to do some either factoring, see if we can split this equation into what two numbers. But with an x squared, that also tells us that we're going to have two answers. We're going to have two answers. So I subtracted 51x from both sides, and I end up with x squared plus a negative 51x plus 32, and I set it equal to 0. When it's set equal to 0, then you can factor it. You can see, okay, what two binomials did I multiply together to get this? Thinking if we're factoring, we want to know, what do we multiply? Well, we take this first term. What did I multiply together to get x squared? Well, x and x. But to get this middle term, what I have to do is I have to find numbers or factors of 32 multiplied together to give me a positive 32. But when added together, the sum of them would be negative 51. Now, if I think about factors of 32, think 8 and 4, 16 and 2, 32 and 1. I know that all of those numbers that I have, none of them will add together to give me a negative 51. So this quadratic equation, we can't factor. We can't factor unless we use some other properties and some other algebra techniques. So this is where we're going to throw in what's called the quadratic formula. How we can throw in the quadratic formula. And I wrote up here the quadratic formula. Notice it says the opposite of b, or negative b, plus or minus the square root of b squared minus 4 times a times c all over 2a. And you say, well, where'd you get all those a's and b's? If you look at a quadratic in standard form, okay, when it's set equal to 0, you're looking at the coefficients. The coefficient on x squared is a, the coefficient on x is b, and the coefficient, or the constant by itself, is c. And that's where we get these numbers. We're going to use those coefficients and that constant to help us solve this quadratic equation. We know that we're going to have two answers because there's two roots of x that will work here. So what we're going to do is, first of all, a, we're going to go back here and look at our equation. We can't factor it. So we're going to look at our equation. A in this case is the coefficient on x squared, which is 1. So here's a, 1. B is the coefficient on x, which is negative 51. And c is our constant, 32. All right, so let's plug that into our quadratic formula. All right, the opposite of b, or a negative b, well, we have a negative 51, which makes that a positive 51. Plus or minus the square root of b squared, so negative 51 squared, that means negative 51 times negative 51, minus 4 times a, which is 1, times c, which is 32, all over 2 times a, which is 1, okay? You look here and you say, okay, 51, if I simplify this, do what's under that square root, 51 plus or minus the square root, and I went ahead and multiplied 51 times 51, or negative 51 times negative 51, and you get 2,551 minus 4 times 1 times 32. 4 times 1 times 32 is 128, all over 2 times 1, which is 2. You say, okay, I can subtract this. I can still do what's underneath that square root. So 2,551 minus 128 would give me 51 plus or minus the square root of 2,423, all divided by 2. Now notice here, 2,423 is not a nice, neat square, okay? There's not a number that's a nice, even whole number that's going to multiply together to give me 2,423. So you can get your calculator out. Notice, though, that you do have two answers here. You have 51 plus the square root of 2,423 divided by 2, and you have 51 minus the square root of 2,423 divided by 2. So you do have two answers there, that x would be, and this sets is equal to x. X equals one of those, which would be 51, and then plus the square root of 2,423 is around 48, around between 48 and 49, okay? So you'd add 51 and then divide by 2, and then you would subtract that number from 51 and divide by 2. And that would give you where, what we're talking about is the x-intercepts, where this parabola, we talked earlier about quadratics graph as parabolas, where this parabola crosses the x-axis, those x-intercepts, where it crosses. And it's going to cross there at those two x-intercepts. So kind of throws in the quadratic formula as well as working with quadratic equations and how we solve quadratic equations to find those x-intercepts or to find those values of x that we need to find. I see Mr. Jensen over here is working through that quadratic formula. How we got that?
So with about 5 minutes, we'll go through half of it.
Okay.
Then back to homework problems and then contest questions.
I
Ms.
think you
Harbison.
have some answers
We
here.
do. Looks like some of those are right.
Ooh, all right.
So I'll do two things. I'll refer to the quadratic, how it's derived, and then better do the contest
All right.
question. Okay. Ms. Harbison was referring to a very important formula used in solving quadratic equations, particularly those where factoring just doesn't seem to be going your way. So she was talking about, let's see, we'll take it back a couple steps. Just how do we, whoever came up with this opposite of b plus minus radical b squared minus 4ac, she said, all over 2 times a. In other words, at that standard form, how do you get all that stuff out of there and you just have x left? So we'll do a couple steps and maybe begin to see how, when we get all done, that this would be the formula that's generated from deriving the formula from solving for x. That is derived by solving for x. Let's see what would make sense to a lot of us. Does it make sense that we ought to subtract c from both sides? So we're beginning to get x by itself, aren't we? And then we'd like to remember what I was thinking. You may say to yourself, well, we're going to solve for x. I could factor out the x, but it's going to double back on me and not do me much good. If we guarantee ourselves that the first term is 1, making that so I have to complete the square here. To do that, if I divide everything, I think, by a, that'll give me x squared over, well, the a's will cancel out, so that's x squared, b over a, x, and then negative c divided by a. Then we're approaching the concept where we need to complete the square, To complete the square, we would take half of the middle half of the BA term and square it. Well, half of BA is B over 2A, and then if you square it, to complete the square it would be, B over 2A squared, and then you'd have to take negative C over A, add that to both sides, and then keep this thing going. You're probably relatively bored by now, but you keep this thing moving, then we can derive the quadratic formula. Coming back to the contest question, because we said secondly in the 5-6 minutes that we have, we would look at a partial derivation of the quadratic formula. Then we come back here. Here are the, and we're down to just what, 3-4 minutes? We're not, so the question was, if you add all these up, plus your next suggested scores, how can you average it out to be 90%? So we're going to go back to the big board, big table, and see what names have come in, Ms. Harbison.
Oh, I've seen this name before.
Eric.
Eric at Anderson.
I will take that one.
Jeff at Beveridge.
That's a good one.
How about Eric at Millard West?
We'll go with that answer.
And Kim from Monroe.
Yes, called it in. So I think we got 3 from which we will draw, Ms. Harbison.
Are you ready?
And then we'll,
Should we draw it and then you're going to work through it?
I think we should.
I think you have about 5 minutes.
And we can do a homework question maybe.
All right. I am going to have Ashley pull one of these. You can do it, Ashley.
Ashley.
All right. Eric from Anderson. Congratulations.
Nice work. Answer 113 and 1. That's pretty tough to get.
Oh.
Let's see if Eric, how you got the 113, give or take. We said that you may want to calculate your present points. So let's add these up. 10, 12, 20, carry the 2. And 8 is 10, 17, 26, 31, 48, 56. I think there's 560 points there. I should check. Right. Plus the next 3. all that at the end of the school year divided by 10, you want that to turn out to be 90. We multiply both sides by 10, get that 10 to cancel out because the inverse of dividing is to multiply. And 10 times 90 is that 900. Obviously, 900 divided by 10 would be that 90%. So we need to take away the present number of accumulated points. 500 from 900 is 400. Drop 60, I think, is 340. So when you divide 340 by 3, we get that 1, which we were seeing. 3 into 4 goes 1. 3 into 10 goes 3 times. And 1 left over, that's 113 and 1/3%. And so it probably is not likely. Not many teachers are going to throw points beyond 100, much beyond it, maybe 2 or 3 points. But get 113 in each time, I think, is a little beyond what you would find in most classrooms. You might see, I typically might have 2 to 5 points in a 2-week period that might be added to the 100 for a 105 maybe, and then of course I have a lot of penalty points. Oh man, well anyway, penalty, bonus, can that turn out to be 113 each and every time? So 113 times 3 is 339 or close to it, 340. So you need 340 points in here, and you can split them up any way you want, but the average is 113. So that's a pretty slick way to determine not only your present status, but where do you want to be in 3 weeks or 5 weeks. So we have the winner, and congratulations, at Anderson Middle.
Congratulations.
Yes. Now,
Eric.
Eric Seitzman.
Uh-huh.
I think, or Sitzman. I think it's Seitzman. What'd you say?
I think it's Hitzman.
Sitzman. Way to go, Eric. I'm tired. I don't know what to say
You're
next.
tired?
Yeah.
What do you think? You worked the last hour?
Bought the wife a car,
I heard.
and those numbers are making me spin. Sitting down trying to understand the lease.
Figuring out those finance charges or
Yeah.
lease charges.
It's a great car. Bought her a Grand Am. She is so excited. From a good
That
place.
will be exciting.
I've been told I can't mention places, but they're a good dealer. If I could tell
Well,
you where to
good.
buy a Grand Am, I tell you.
Well, we have to say thank you to these young ladies, Carolyn and Kylie and Ashley. They did an excellent job up here. If you got a chance to talk to them, give them your math question tonight. They did a great job. They make our job so much
Oh, they
easier. We have to
did.
say thank you to Mrs. Corsier for
She
bringing
came.
them. She
We
came.
We can't highlight her, can we?
She asked. I know she
Yeah,
said she said, do not let Mr. Jensen do anything.
Nobody's budging, so she gets her own way this time. How many more shows, Miss Harbison?
Just 2.
2. Ah, the
Uh,
famous Miss Corsair. She has no microphone.
Good.
Yep. Okay, raise your hand in the audience if she was your teacher. Yeah, yeah. Look at them. See, they're running down here.
These ladies didn't raise their hands, of course.
Wait a minute. Okay, well,
Thank you.
bye now.
That's it. That's it, Miss Carey. Get her off the set.
2 more shows. Mr. Jensen will be back next Tuesday. You'll be here.
If we don't mess up, we might be back next year.
We'll keep our fingers crossed. Keep doing those math problems and have a good week.
Night.
Homework Hotline is a production of the Knowledge Network of Greater Omaha, originating from the Career Center of the Omaha Public Schools. Homework Hotline is made possible in part by Nebraskans for Public Television.